In this lesson, we will calculate the number of protons, electrons, and neutrons for a given element. We will also learn that most elements have two or more isotopes. Modern atomic theory states that atoms are composed of protons, which are positively charged particles located within the nucleus. Neutrons are uncharged particles located within the nucleus. Electrons are negatively charged particles which orbit the nucleus. All atoms can be identified by the number of protons and neutrons they contain. The number of protons in the nucleus of each atom of an element is called the atomic number, represented with a Z. In a neutral atom, the number of protons is equal to the number of electrons. So the atomic number also indicates the number of electrons present in the atom. The chemical identity of an atom can be determined solely by its atomic number. For example, the atomic number of nitrogen is 7. This means that each neutral nitrogen atom has 7 protons and 7 electrons. The mass number, represented with an A, is the total number of neutrons and protons present in the nucleus of an atom of an element. The number of neutrons in an atom is equal to the difference between the mass number and the atomic number, or A minus Z. We will now write the number of protons, neutrons, and electrons for nitrogen. The number of protons equals the atomic number, 7. The number of neutrons equals the mass number rounded, and it needs to be a whole number, minus the atomic number, and that gives us 7. The number of electrons equals the number of protons because this is a neutral atom. We will now write the complete symbol for nitrogen. X stands for the element. A stands for the mass number, and this needs to be a whole number. So not the whole entire mass number, but a whole number. And if it needs to be rounded, you need to round it. 14. The number of protons goes on bottom, and that is 7. In this practice problem, determine the number of protons, neutrons, and electrons present in the following atom. The number of protons equals the atomic number, 79. The number of neutrons equals the mass number minus the atomic number, 118. The number of electrons equals 79, the atomic number, because this is a neutral atom. Write a complete symbol for an atom whose nucleus contains 15 protons and 16 neutrons. Since 15 protons are present in the atom, the atomic number of the atom is 15. Atomic number 15 belongs to the element phosphorus. The mass number of the atom is obtained by adding the number of protons and neutrons. The mass number is 15 plus 16 equals 31. Isotopes. Though all atoms of a given element have the same atomic number and therefore the same number of protons and electrons, they need not all be identical. They can differ in the number of neutrons present. The presence of one or more additional neutrons in the tiny nucleus of an atom has essentially no effect on the way it behaves chemically. For example, all oxygen atoms have 8 protons and 8 electrons. Most oxygen atoms also contain 8 neutrons. Some oxygen atoms exist, however, that contain 9 neutrons, and few exist that contain 10 neutrons. So, 3 different kinds of oxygen atoms exist, all with the same chemical properties. We define isotopes as atoms that have the same atomic number and differing mass numbers. Isotopes will always have the same number of protons and electrons and differing numbers of neutrons. We name these after their mass number: oxygen 16, oxygen 17, and oxygen 18. I will now have you practice by filling in the following chart. I will help you do the first one. Uranium. The symbol for uranium is U. The number of protons, 92. The number of neutrons is given, 143. The next thing to do is to name this isotope. In order to do that, we need to find the mass. So we will take 143, the number of neutrons, plus the number of protons. 143 plus 92 is 235. We name this uranium 235. Welcome back, and let's see how you did. Uranium, the symbol is U. The number of protons is the same. The protons for uranium or any element never changes. The number of neutrons in this case did change. It went from 143 to 146. To name this isotope, we need to find the mass. 146 plus 92 is 238. This element is uranium 238. Our next element is carbon. The number of protons in carbon, we look at the periodic table, and it's the same as the atomic number, which is 6. The chart says that it has 6 neutrons. To name the isotope, we need to add these two together. 8 plus 6 is 14. And this is carbon 14. Iodine is next. Iodine. The atomic mass for iodine, we look on the periodic table, and it is 53. The number of neutrons is given, it's 78. To name this element, we need the mass. So we take 78, the number of neutrons, plus 53, the number of protons, and we get 131. Iodine 131.